Okay, so today we're talking about function notation and we're evaluating, and then we're going to do some graphing later on. So first, for problem A, we're going to start with problem 1a. G of x equals negative 2x minus 3. For these, where we're evaluating at a specific x, we're just going to swap. We're going to replace the x's with our 4. We just need to replace every x with a 4. So we're going to say G of 4 equals negative 2, and we're going to put 4 in parentheses, minus 3. So G of 4 equals negative 2 times 4, which is negative 8, minus 3. Negative 8 minus 3 is negative 11. So G of 4 is negative 11. And then for h of x, we're going to do h of 4 equals 7 times 4 plus 15. Okay, 7 times 4, 28. So h of 4 is 28 plus 15. 28 plus 15 is going to give us 43 for our h of 4. Okay, and so that's all we had to do for those two. We're just replacing our x's with whatever it's telling us to evaluate at. These ones are going to require a little bit more. So first we want to find our slope for writing our function. And so to find our slope, we're going to do the change in y divided by the change in x. Okay, so here we see x is just from 1 to 2, we're adding 1, 2 to 3, we're adding 1, 3 to 4, we're adding 1. For f of x, we see we're adding 6.5, 6.5, and 6.5. So our slope is going to be the change in f of x, which is 6.5, divided by our change in x, which is 1, so 6.5. Okay, and now we have to find our b. We have m, but we need to find b now. So we're going to start with our form for an equation, slope-intercept equals mx plus b. So we have m, so 6.5. And now we're just going to pick one of our points to use as y and x that we're going to use to solve for b. So f of x in this example was, we'll use this point, we'll use point 2, 13. So this equals 13. X in this case was 2. So we'll have a 2 right there, plus b. And so now we're just solving for b out of right here. This is going to become 13. We're still adding b. And then obviously we'll subtract 13. These cancel. This becomes 0 equals b. And so our linear function for part A is going to be f of x equals 6.5x plus 0. Or just 6.5x. You just cut it off there. Because our b was 0 and our m was 6.5. Now, for part B, still in the x's, we're adding 1. But down in f of x, we're adding 3 each time. And we already said that m is our change in f of x divided by our change in x. So here, m will be 3 divided by 1, which is just 3. And then same as last time, we're going to use our f of x equals mx plus b to solve for our b. So f of x equals mx plus b. We know m is 3. And we're going to pick one of our points. Let's use 2, 4. So here f of x was 4, x was 2, and then we still have b. So this gives us 4 equals 6 plus b. So we're going to subtract 6. I'm going to go over here. Subtract 6. and this is going to give us negative 2 equals b. And so from there, we have b and we have m already. So f of x equals 3x minus 2. And that's all we needed. We found our slope, and then we used it to find our y-intercept, and now we have our full equation right there. Okay. Now we're going to do some graphing. So we've seen this form before. This is slope-intercept form. In this one, it's just a little harder to see because our m is hidden, but it's just a -1 that's in front of that x. There's just a -1 right there. And we have our intercept, if we're thinking about slope-intercept form. Our b value here is just 1. So we know our y-intercept is going to be at 1. And we set our slope here, our m, was -1. Which means our rise over run is just -1 over 1. So for every time we go to the right 1, we have to go down 1. So starting at our y-intercept, we're going to go to the right 1 and down 1. And that'll give us our line. This one, we have the same b value of 1 for part b. So once again, we're going to start at 1. But now our m, our slope, is positive 3. So thinking about rise over run, we have to go up 3 for every time we go to the right 1. So starting from our y-intercept, we're going to go to the right 1, and then going to go up 1, 2, 3. And then connect those 2 points. And that'll give us our graph for that one too. Okay, and now we're going to do problems 5 and 6. So starting with 5, we're evaluating f of x equals 4x minus 3 at both 2 and 6. So we'll do 2 first. So here we have f of 2 equals 4 times 2 minus 3. I just put this 2 in place of both x's. F of 2 equals 4 times 2 minus 3. And this is going to give us 8 minus 3, which is going to be 5, is f of 2. And then for f of 6, we're going to do the same thing, replacing x with 6 this time. This is going to give us 4 times 6 minus 3, which is 24 minus 3, which is 21. So we just subbed in our 2 at x, and we subbed in our 6 at x. And now for problem 6, f of x equals negative parentheses x minus 2. So f of 2 is going to be negative parentheses 2 minus 2. This is just going to become 0 in the parentheses, and so negative 0 is still just 0, so f of 2 is 0. And then f of 6, it's the same process as it has been, negative 6 minus 2. So we're going to have negative in parentheses 4, which is negative 4, equals f of 6. That's all we had to do. We're just subbing in our values for x's, and then we're simplifying.